9.5 meters below space and time. This crash did it for how much interest? Well, I'm going to take this vector equation.
Alright, welcome back to Physics Teacher. This is our second episode for coding math in Python. I'm hoping you're enjoying the series. Today we are going to be plotting expressions and learning how to substitute values and solving expressions as well. So let's start with plotting expressions. So first to plot, we're going to need to import some functions to be able to do that. We're going to import them from Simpy, so symbolic Python. And they have their own plotting feature. So simpy.plotting, import plot. Now to plot an expression, we're going to need to define variables. So we're going to need symbols as well. So from Simpy, import symbol. Now we learned about symbols from the last episode. So if you forgot, please go and watch that and then come back. So we're going to start by defining x as a symbol. We're just going to define it as x. And now we're going to plot something. We'll start with something linear, like a linear function. For example, 2x plus 3. So if I want to plot 2x plus 3, I simply use the command plot. And inside of brackets, I write 2x plus 3. And that's it. Now if I run that code, hit run. It looks like nothing happens here because I forgot the star. It's a typical mistake. Computers are very, very picky, and especially since we write things as 2x, I sometimes forget to write 2 times x. So again, if you forget something like that, the computer will yell at you, and you just need to look for that little picky thing that you have to fix. So if I run that again, now no errors, still don't see a graph, because the graph will appear up here. This is different windows up here. Right now I have it on the help window, but if I switch to the plot windows, there's your graph. Now let's say we wanted to show different things. Say I didn't want to see all of this from minus 10 to 10. Maybe I just wanted to see from 0 to 5. So what I can do here is inside of the plot function, I'm going to put the expression in brackets. And then still within inside those brackets for the plot functions, I'm going to do comma, and then another bracket where I'm going to say, I want to see x between 0 and 5. So now if I run that code, there's our new graph between 0 and 5. And we can add a whole bunch of other stuff as well. We can add, or if you want, we can even plot a different function. Let's try a quadratic. Let's try minus 3, oh, I almost did it again, 3 times x squared plus 11 times x, and let's say plus 4. So we want to graph this. Let's graph it between minus 2 and 5. Okay, but what we can also do is we can add a title to the graph. We can add labels for the axes as well. So let's do that. So still inside of these main brackets for our plot functions, I'm just going to separate everything by a comma. And let's have a title. So title equals, and then single quotes if you're going to type a script. And let's do non-uniform motion. And then we're going to separate that with a comma and have our x label, which means to label the x-axis, and we're going to label it as time. And then again, let's do the y label as position. So once we're done all that, we can run. And there we go. So here's our title, non-uniform motion. Our y-axis is labeled position, x-axis time, and it's showing between minus 2 and 5. Now notice whenever I put an expression in, Python assumes that expression is equal to y. If it's equal to something else, you need to rearrange and solve it. If you want Python to solve it for you, I will show you the code to do that later in today. today's lesson. But another really cool feature is you'll notice all the previous graphs that I've done are here as well. So I can go back and look at any of them. All right, so next thing what we're going to do is learn how to substitute values into an expression. So let's start over here again. But we are going to need to, from simpy import, we're going to need symbol. Since I'm going to work with expressions, I want them to come out nice and pretty. So I'm going to import pretty print to make it look like something that we would write by hand. Right? That's a function we went over in the last lesson. All right, so let's use the variables x and y. So I'm going to have to define them. So x equals symbol. You don't actually need that space. I just like it. As x, and y equals symbol as y. You do need a capital S on the symbol though. All right, so we have x and y, and so let's come up with an expression. So I'm going to say the expression, I'm just going to call expr. You can call it whatever you want to. I'll just call it expr. Let's work with x squared. So x squared plus 2xy. So 2 times x times y. And plus, let's do y squared. All right, so there's an expression. Now say I want to substitute values into that expression for x and y. Let's say x equals 1 and y equals 1. I can do that using the subs command. And I am going to type the expression dot subs. And then that function has brackets. And then the values we're going to substitute are going to be inside of curly brackets. We're going to say x equals to 1. Right? But we're assigning x the value of the ones. We're not really saying x equal to. We're going to use a colon, right? Not an equal sign. And y is 2. All right, now if I simply ran the code there, I mean, I can do that. We don't get any errors, but we don't get anything outputted either. Reason? We didn't ask it to output anything. So what I'm going to do is I'm going to go back up here and ask it to pretty print that whole thing. And so I'll put brackets around the whole thing for our pretty print function, hit run, and now you get 9. So once we substitute 1 and 2 in for x and y into this expression, you get 9. So that's a great feature to know how to do, how to substitute values. But the interesting thing is we didn't have to substitute numbers, right? I've labeled y and x as variables. If I wanted to, I could have simply substituted x in for 1 minus y. Now if I do that, what happens if I run? So I get y squared plus 2y times 1 minus y plus 1 minus y squared. So you can see it pretty much directly substituted 1 minus y, and it didn't really simplify it for us. So what if we want it to be simplified? We can do that. Right? We're going to import another function called, well, simplify. Okay. So I've imported this function called simplify, and what I'm going to do here then is I'm going to pretty print, and I'm going to simplify this entire expression substituting x as 1 minus y. So I'm going to type in simplify, and then put all of that in brackets. Once you have so many brackets in, you're going to have to make sure you've opened and closed every bracket you put in there, or else you're going to get errors. Right? Another picky thing the computer likes to look at. But if we run it, we get 1. See? Much more simplified. And you can test that yourself. Write that down, that expression down, expand it, simplify it. It actually does reduce to 1. So it works out great, except the computer did it all for us. All right, so the last thing I'm going to do in today's episode is sort of an expansion of what we did yesterday. So yesterday we learned the basics, how to add, subtract, multiply, divide, take square roots, exponents, and so on. And then we actually tried applying the quadratic formula. It was pretty messy. However, today we're just going to tell the computer to do all that on its own. So let's start over again. I'm going to keep the symbol x. And we do not need simplify. But we are going to need a new function. We're going to need the function solve. All right, so let's take an expression, and let's say you have a quadratic equation, but you're going to rearrange that equation so that it equals 0. That's extremely important. So whatever you put in for the expression, it must equal 0. That's what Python assumes. So let's say we have x squared plus 5 times x plus 4. So it's assuming that whole expression equals 0. Now we can simply solve that by saying solve. What we're going to solve for is the expression, and we are going to solve it for, we're going to write dictionary equals true. Now later I'll show you in another episode how to solve an expression that has more than one variables for a specific variable that you want to solve for. But in this case, we're just rearranging that expression which equals 0 to solve for the values of x. And because we know it's a quadratic, it is going to have more than one value. And so what we want is all those values to be returned as a list in the Python dictionaries. So that's what this is saying. Dictionaries equals true, meaning it's going to return it as a list. So we're going to have all those values there for us. Now again, if I run that, it should be fine, but it's not going to spit out anything. So to get it to output something, let's have it pretty print all of this. Check your brackets, right, and run. There you go. Outputted as a list where we have two values in our list, x being -4 and x being -1. All right, so I hope you enjoyed this episode, and I'll see you in the next episode.